Linear systems, the basics. There are two basic ways to solve linear systems of equations. One is elimination, which I grew up calling elimination by addition, and there's some other way I've heard, and I don't remember the name of it right now, but there's other names to this. So if you see it, you go, oh, that's what I'm doing, but it's not called that. That's fine. All right, and then substitution. Those are the two basic ways, and I'm going to call basic for the purposes of this video. I will introduce the ideas of both of these methods using two equations with two unknowns. This is as basic as it gets. All right, so these methods are expandable to larger systems, but the level of difficulty increases with each additional unknown. So if you go to 3 unknowns, X, Y, and Z, or A, B, and C, or whatever, it gets harder than 2. 4 gets harder than that. 5 gets harder than that. And really, about the time you get to 4 or 5, you don't really want to be using one of these two methods. You probably want to use something else. But to solve a system of equations, the number of equations, you need to have the number of distinct or unique equations that needs to equal or be greater than the number of variables for you to be able to solve it. Okay? So as long as you have as many equations as you do variables, then you can solve a system, even if it's 10 equations with 10 variables. All right? I want to make a note here. Matrices, augmented matrices can also be used, but I'm not considering that as basic for this video. Okay? To me, the matrices are a little bit more advanced method and technique there. So we're going to start with this and then understand matrices are there. And quite frankly, if you get to 4x4, then matrices is going to be a little bit more efficient even at 4x4 than 4 equations, 4 unknowns. Matrices are going to be better than doing it this way, most likely. Unless it's a special case that just kind of works out pretty quick and easy. And then, of course, I've seen worked with people before, a professor at a university. He was world-renowned and considered by many in his field to be a top 5 what's called a computational engineer in the world. And he got a $3 million grant for his university, does some major work with creating ships, helicopters, airplanes, things like that. So he has supercomputers and literally feeds in millions of variables and information into that in equations and solves them so that he can get a really good working prototype for whatever he is designing on the first try. Unlike the Wright brothers who had to try over and over and over again, right, to fly a plane. He can go in his computer and enter all this stuff about air pressure and wind speed and mechanics of the materials that you're going to make the plane out of and all this other stuff, and say, okay, here's all these variables in there, and boom, put it in the computer. Oh, you can't make it out of that. It won't make it. Okay, well, that's good. We didn't test it, right? And so that kind of thing. And get a really good. So that's where this is going. You can go so much bigger and have so many more uses in the real world for this. This is the basics of it, okay? The basics of it. So the goal of both methods is to obtain one equation with only x's or only y's. If I can get it down to one equation that only has one variable in it, then guess what? I can solve it, and that's really the goal for any of these, but especially for the 2x2. You do the same thing with the 3x3. You got to get it down to 2x2 and then down to 1x1. You know, one equation, one unknown. So how do I know which one of these to use if I'm not told? All right. So sometimes what I mean is you get instructions in the book, or your teacher says, hey, use elimination, or hey, use substitution. But what if they just say, hey, solve, which is what I'm going to do in this video. I'm just going to say, hey, solve. So I'm going to focus on identifying because, again, I say in math, we math teachers, and I'm saying I'm included, we do a real good job of teaching students steps. We don't do such a good job of teaching students when they should do those steps. And that's why I think a lot of students struggle in their algebra classes, because they know a lot of algebra steps. They just can't figure out when I'm supposed to use this step versus another step. So I do a whole lot of trying to diagnose what to use, and that way I can get the problem. Because, if I start out using the wrong thing, then I'm not going to get it right. It's just not going to work. So while this is not a comprehensive list that I'm about to give you, and sometimes it's simply a matter of preference, okay, it just is, all right, I use the criteria below in this order, okay, to determine which method I'm going to use. So if either equation is already in the form x equals or y equals, I go straight to substitution, because I have x equals something in terms of y, or y equals something in terms of x. And I should clarify, there's no x's on the other side or no y's on the other side. Like x equals something just in terms of y. Y equals something just in terms of x. Okay? So, or x or y equals a number, but no x equals something with x on the other side. All right? If adding the two equations immediately eliminates a variable, use elimination. So what I mean is if I have one equation and it says blah, 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 plus 3x equals 7 and blah, 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 minus 3x equals 6, then I'm just going to add them together because plus 3x and minus 3x cancels out, okay? And I know that adding two equations together might be a new concept for us, but I would just line up the equals and line up, try to get my like terms under each other on whatever side and put them together, okay? Just add them together. If either equation has just an x or just a y and the coefficient of either of those is 1, okay? So if you have 3y plus x equals 7, or 9y plus x equals 8, or 5x plus y equals 10, then I'm going to solve for that x or y and then use substitution, okay? I'm going to solve for that x or y and then use substitution. And then finally, if neither equation has just x or y with a coefficient of 1, meaning every x is 2x, 3x, 5x, minus 8x, minus 2x, minus 8x, or 6y, or 10y, or minus 8y, minus 11y, I'm going to use elimination, okay? And under this last one here, there's a lot of different situations, or three main situations that can occur, and I'm actually taking care of one of them by the second arrow up here. So this is the order that I go in here, because it's possible these two could have overlap, but I'm typically going to use elimination if I can add them together immediately and get rid of something, as opposed to solve, because that's an extra step, okay? The easiest scenario is when you can simply add the two equations together and eliminate a variable for elimination. This is elimination, by the way. For elimination, the easiest scenario is when you can simply add them together and eliminate a variable. The next simplest scenario is when you can only multiply one equation, or when you have to only multiply one equation by an integer and then add the equations together. All right? So this happens when the coefficient of one variable is a multiple of the coefficient of the same variable in the other equation. What I mean is if I have plus 3y and minus 9y, then these are multiples of each other. I can just multiply this top one by 3, and then I get plus 9y, and I have minus 9y, and they cancel out whenever I add them together. That's what I mean by that. They're multiples of each other. All right, so do you think that always happens? No. All right, so then the most complicated way for this to work is if nothing like that works, but this way here will what? Always work. I love always work, okay? You can always do this. No matter what order you want to go in or how I choose my preferences, I do the other stuff because it's shorter than this. But this way here always works. You can always use this. You can multiply each equation by the coefficient of that variable from the other equation and change the sign of one of them. Change one sign before you multiply, okay? So what I mean is if I have 2x and 5x in my two equations and I have other stuff in there, then I swap the 5 and the 2. I put a 5 up here and multiply by this equation and a 2 down here, and then I change one sign. That's what I mean. Swap the two coefficients and change one of the signs. And inside that, if I have one of my sets of coefficients that one's positive and one's negative, then I just change the negative coefficient to a positive is what I do. And then I'm dealing with fewer negatives. I always like to deal with fewer negatives. All right? For substitution, the best case scenario is when an equation is already in the form x equals or y equals with the same variables not on the other side. X equals something that doesn't have x in it. Y equals something that doesn't have y in it. That's the easiest, best scenario. The other scenario is when either equation has just an x or a y. The coefficient of either is 1. Then solve one of the equations for x or y, all right, and proceed from there. Any other scenario may result in fractions, so then I use elimination. All right. So if all my coefficients are not 1 on x's and y's, you can still use substitution, but you may have a lot of fractions involved, and I don't know anybody that likes to use fractions. Okay, you can say you do, but you're probably telling me a story. Okay, so I mean, I'm okay with fractions. I can do fractions all day long, and I don't like to use them. I know all the teachers are going to send me hate emails for that, right? Once you have x equals or y equals, use that to substitute the expression equal to x or y to the other equation. This is overall. Once I get x equals or y equals, well, in this case, I'm sorry for substitution, I have an expression, then I substitute it in for the other one. Whether it's already in the form of x equals or I had to solve for x equals. I take that and plug it into the other equation. So let's look at some examples. So when I look at this, I have y equals and there's no y's over here. Okay? So then I'm going to choose to use substitution because of that. Okay? This is my A1 first choice. I already have x equals or y equals. I'm going to go straight to substitution. So what I'm going to do is I have y equals this. So I'm going to plug this in for y in the other equation. I don't care how complicated it is, plug it in for y in the other equation. So in the other equation, if I take this equation right here and I start writing it down, right? X plus y. Wait a minute, what was y? Y was 2x. And sometimes this has to be in parentheses. In this case, it doesn't because it's a single term, and there's a plus in front of it, equals 6. So you see what I did? I took this 2x and I plugged it in right here for y, right? Plugged it in for y. So that's what I'm going to do with that, all right? Plug that in for y. So when I do that, now I get x plus 2x equals 6. So that's 3x, if I add those together, equals 6. And then divide by 3, x equals 2. X equals 2. So down here I have an OR. So I have an ordered pair over here, which is x, y, right? And then here x equals y equals on this side. So let's plug these things in and see what happens, all right? So x equals 2. So I can go ahead and put a 2 in here for both those values, whichever way you're asked. My guess is you're going to be asked one or both of those ways. So x equals 2 or 2 goes in the first part of the ordered pair because I found x. If you find y first, just put it in the second part of the ordered pair, right? It's x comma y. So 2 is the x value. How do I go back and find the y value? Well, look, y equals 2x. I found it, so now go plug it in. I have here y equals 2 times x, right? But wait a minute, what is x? X is 2, isn't it? So then what does y equal? Y equals 2 times 2 is 4, so then 4 goes in here. Anytime you solve these, whatever equation I use, I just used this equation to get the second variable, right? Test it in this one. Just check it here. So I have 2 plus 4. What is 2 plus 4? 6 equals 6. Checks out, right? It checks out. Just whatever equation you use to find the last value, whether x or y is the last value. If you use the top equation, check it in the bottom. When you use the bottom equation, check it in the top one. They may be left and right for yours, but I have it, up and down. And look, this little symbol here is used, I'm using it, and it's used in the book I currently teach out of and in other books I've seen as saying, hey, this is a system of equations that goes together. And you could have that bracket, that little squiggly bracket thing could be much bigger. And say, hey, it's got 5 equations or 6 equations or whatever, but here I only have 2. So that's all we're going to focus on is 2. All right, so let's look at another one. Oh, I just saw that line. If y'all rewind the video, I had this line come across here right there, okay? That tells me that this thing's about to go haywire, so hopefully it will make it. A little glitch in the software. All right, so 3x plus 2y equals 14. 3x minus 2y equals 14. So the first thing and hang on, I'm going to see if I can fix that glitch a little bit. All right, so the first thing I look for, is it already x equals or y equals? No. The next thing I look for, well, if I just add them together, do I eliminate a variable? And the answer for that is yes. If I add them together, look what happens with plus 2y minus 2y. If I just add those two equations together, those cancel, okay? So I'm going to do that. I'm going to come down here, and I don't like to mess with my original problem very much, so I'm going to rewrite it here. 3x minus 2y equals 10. And I'm just going to, when I say add them together, I mean don't change any signs. I'm not going to put a plus sign out here. I'm not changing any signs, and then I'm combining like terms. So 3x and 3x, they're both positive, is 6x. This cancels. 6x equals how much? 24. So I don't like all that space there. So if I come over here and say 6x equals 24, we divide by 6, and then we get x equals 4. So then in my x blank, I can put 4 or first here. And again, you don't always find x first. It just happened to work out that way here because when I added them together, my y's canceled out. All right. So that's what I mean by I look at this thing, and if I can just add them together and something cancels from the start, then that's what I'm going to do, and that's what I did here. All right? That, to me, that's the second easiest thing there. The first is substitution, plugging in. This actually you might think is easier than that. But those two things are kind of the easiest ways to do this. And they obviously don't happen very often, but in case they do happen, you need to be looking for it, okay? And look, some of you say, well, why does this help me later on in my life? Why? Because whatever you do in life, you need to be efficient. So if I'm solving problems, if I'm solving the same kinds of things at work, doing the same kind of projects over and over and over and over again, okay, and I only know one way to do it, and it takes me 15 minutes to do this when it should have taken me 3. I'm not very efficient, and my company's not going to like that very much. Whereas if somebody else that does the same thing as you can do that in 3 minutes, and they get 5 of them done while you do 1, then when the promotion comes up, right, if your daddy doesn't own the place, or your granddaddy or your mama or somebody, right, then they're going to get the promotion because they're more efficient. So it's all about being efficient. And that's what everything in life is, solving an issue or problem. And I'm not only problem like it's a bad thing, but I just mean there's something that needs to be done, and if you can do it efficiently, that's better than doing it inefficiently. So here, I'm trying to be efficient by identifying, hey, just add them together and those cancel. All right? So now I know what x is. X is 4, so I want to get y. So I'm going to choose this one. It doesn't matter. You can choose either one in this case. I'm going to choose this one. So 3 times x plus 2y equals 14. All right, well, what is x? We said x was what? 4. So I'm going to plug in x, so 12 plus 2y equals 14. And then subtract 12. And by the way, this would work if you chose the bottom equation. You should get the same answer that I get here. So then y equals 1. So 1 goes in here. And whatever, I don't like that one there. Whatever equation I used, I check it in the other one just as a quick check, right? I used this one, so check it in this bottom one here, right? So 3 times x, 3 times 4, right? 3 times 4 is what? 12. And then minus 2 times 1 is what? 2. Is 12 minus 2 10? Yep. All right. So whatever one you use to solve, check it in the other one. There, 4 is 3 times 4 is 12, and then minus 2 times 1, so 12 minus 2 is 10. It checks out. 10 equals 10. All right. So let's erase this now from that. So 3x minus 2y equals negative 5, and x equals 4y plus 5. So here, I look at this, I go, oh, wait a minute, look what I have. I already have x equals. So I'm going to use substitution. I didn't write that down on the last one. I was going to use elimination, but I'm going to use substitution here. Ooh, I'm going to use substitution because I have x equals. So if I have x equals, I'm going to take all of this and plug it in for x. Okay? I'm going to plug it in for x. So let me come down here and say, okay, in this equation, I have 3 times x. I got to leave a lot of room because I have 2 terms there, right? Leave enough room for 2 terms here. Minus 2y equals negative 5. And what am I plugging in there? I'm plugging all of this in here, right? So 4y plus 5. 4y plus 5. So now we're going to distribute this. We get 12y plus 15 minus 2y equals negative 5. And look, I've got to put this together with this. And look, there's nothing else to do with this term except move it over. So I'm going to save a step and do that on the same step here. You can do it on this next step or a separate step, and I'm going to do it right here. That cancels. 12y minus 2y is 10y equals negative 5 and negative 15. We add those together, get 20, and keep it negative. So negative 20. So 10y equals negative 20. And then I divide both sides by 10. Divide both sides by 10. So y equals negative 2. So this time, second part of my order pair in the y equals is negative 2. All right? Is negative 2. Now I need to go back and find what? I need to find x. Well, how do I find x? I know that x equals 4 times whatever I got for y plus 5. But don't I know why? I sure do. Y is negative 2. So I plug it in. And so now I get x equals negative 8 plus 5. And again, negative 8 plus 5, you subtract and get 3 and keep the sign of the larger. So x equals negative 3. So negative 3 here. And again, I used this one to solve for x, right? The second variable. So then check it here. Check right there, okay? So if I check it right there, I'm going to say 3 times negative 3, right? 3 times negative 3 is negative 9. And then minus 2 times negative 2, so minus 2 times negative 2 is plus 4, right? Negative times negative is positive, 2 times 2 is 4. So negative 9 plus 4 is negative 5. Does that equal negative 5? Check. That works out. That works out. So you always just, even if it's just a quick mental check there, just go plug it in the other one and check it to make sure it works out. If it doesn't work out, you probably just made a careless mistake somewhere along the way. You added when you should have subtracted, or you didn't divide right, or added an extra 1 to something or something like that. All right. We all make careless mistakes, and when I say all, I'm including myself. Okay. We all do it. You've seen it on my videos. I'll write something down and be like, oh, that's not what that is. X plus 3y equals 8 and y equals 2x minus 9. I look at this and I go, oh, y equals substitution. No doubt about it, right? So I'm going to take all of this and plug it in for x. So we're going to say x plus 3y equals 8. And I don't necessarily have to have parentheses here because there's nothing out front, okay? If there was anything, even a negative sign, I'd need parentheses there. But I'm going to put them there just for emphasis sake. 2x minus 9. And I plugged in the wrong thing. See, careless mistake right there. I wanted to show you what was going on. No, I just messed up. All right. Y equals, right? This doesn't go in for x. This goes in for what? For y. I wanted to be crazy for a minute. Now, you can all quit screaming at the screen now, right? X plus 3 times whatever's there equals 8, right? Because this goes in for y, not for x. So then here, this is going to be what? 2x minus 9. Right, I had to display right there firsthand, right after I talked about careless mistakes, right? That we all make them. So I wish it was on purpose, but it wasn't. I just messed up. All right. But here we're on the right track, right? And that's what happens. Look, sometimes in math you do that. You start down the road and you go, I got to go fix it. Okay. So here we went to fix it. So now I'm going to distribute my plus 3. I get x plus 6x minus 27 equals 8. And I have to put these two together. And again, let's just go ahead and move that over. Just go ahead and move that over. So I'm going to add 27 to both sides. So that cancels. We get 7x equals 35. And we divide both sides by 7. And we get x equals 5. So 5 here and 5 here. But for y, I have y equals 2 times x minus 9. But what is x? X is 5. So what is y? Y is going to be 2 times 5, which is 10 minus 9. So what does y equal? 1. Y is 1. So again, I used this bottom equation to find y. So check it where? Check it here. Okay? So if I do that, x is equal to 5, so this is 5, plus 3 times 1 is 3. Now, if that had been minus, I could have just changed that plus. But 5 plus 3 is what? 8. Does 8 equal 8? Yep. So there it is. 8 equals 8. It checked out. It worked. All right. For this one, 3x minus 4y equals 11. 5x plus 8y equals negative 11. If I look at this, I don't have x equals or y equals. I can't just add them together and something cancels out. And I can't solve for x or y really easily because all of these things are not 1. All those things are not 1. I need to circle those negative, that negative there with that 4y. So I'm going to use that method where I eliminate and I say, okay, first of all, can I simply, since I can't just add them together, can I multiply just one of them by something and something cancel? So if I look at the x's, that's not possible. You can't do 3 times something and get 5, not a whole number or integer. But here, 4 and 8 are multiples of each other, so I want one of those things to be 8, which it already is, and the other to be negative 8, okay? So I can multiply the top equation. If I multiply that by 2, I get negative 8y. So let's take the top equation. So 2 times 3x minus 4y equals 11, okay? 2 times 3x minus 4y equals 11. Distribute the 2 to all three things, even on the other side of the equals. It's a little weird for us to talk about multiplying an entire equation, but it's both sides by 2, and then we add equations together in this as well. It's kind of a new thing, maybe. 6x minus 8y equals 22. Now I do a mental check, and I say negative 8y plus 8y. That's going to work, right? Now I can add them together, and it cancels. So I'm going to simply copy this equation down here. 5x plus 8y equals negative 11. And when I do that, 6x plus 5x is 11x, minus 8y plus 8y is 0. It cancels, equals 22 minus 11 is 11. Divide both sides by 11, and I get x equals what? 1. 1. X equals 1. So how do I find y? Well, I'm going to use the top equation. You can use either one, but I'm going to use the top one. Okay. So I'm going to say 3 times x minus 4y equals 11. What was x? It was 1, right? So 3 times 1 is 3. So 3 minus 4y equals 11. I'm going to subtract 3 from both sides. Negative 4y equals 8. Divide by negative 4. What do we get for y? 8 divided by negative 4 is negative 2. So y equals negative 2. So let's plug it in here. And since I used the top equation to find my last variable y, I'm going to check it in this equation. Okay? So if I check it there, let's see. 5 times 1, right? What is 5 times 1? That's 5, right? And then 8 times negative 2. What is positive 8 times negative 2? That's minus 16. And 5 minus 16 is negative 11. And guess what? That checks out, doesn't it? So I went through there, and I know I wrote all over it, but I'm going to take that off. So it checks out, so that works out there, and that is the correct answer, 1 comma negative 2. 5x minus 2y equals negative 2, and 3x plus y equals negative 10. So here, do I have x equals or y equals? No. If I just add the two equations together, do I eliminate something? No. But I do have this right here, plus y. So I'm going to choose to solve this equation for y and use substitution. So 3x plus y equals negative 10. You can multiply that equation by 2 and add it to the one above it. That will work, okay? But I choose to do substitution in this case. It's a matter of preference. There's other ways to do this one. So I'm going to subtract 3x from this both sides. That cancels. Y equals, and it doesn't matter what order, but I'm going to put it in descending order. But you can put negative 10 minus 3x. You just can't combine those two because they're not like terms. Okay? So whether you put negative 10 minus 3x or negative 3x minus 10, that's the same thing, but they're both negative. That's important. So now I know what y is. I'm going to take this and plug it into the other equation for y. Okay? Plug it into the other equation for y. So we're going to say 5x minus 2 times y equals negative 2. And what is y? Y is negative 3x minus 10, right? This goes in here. Let me get rid of that there. All right. So now solve this equation because now we only have x's, right? Just x's in this equation. So 5x and then distribute this negative 2. So it's plus 6x because negative 2 times negative 3x is plus 6x. Negative 2 times negative 10 is plus 20 equals negative 2. And then we are going to combine these and get 11x. And at the same time, I'm going to go ahead and move this 20 over by subtracting it, okay, because it's already simplified on that side, the 20 is. So then subtract it from both sides, you get negative 22. Divide both sides by 11, and you get x equals negative 2. X equals negative 2. So I'm going to put negative 2 in for x. And then I want to go back and find y. I'm going to plug this in for x here to find it. Okay? So y equals negative 3 times x minus 10. X is negative 2. So then what is negative 3 times negative 2? It's positive 6 minus 10 for y. So what does y equal? Negative 4. Negative 4. So I used a version of this equation to solve for y. Even though I didn't use that exact equation, I manipulated it, which means I could have made a careless mistake or something, right? Or just a mistake. So I'm going to check it in the top one. Okay, I'm going to check it up here in this one. Doesn't matter. You can check it. But that's since I used a version of the bottom equation to solve for the last variable, check it up here. So we have 5 times x, which is times negative 2. And then 2 times y, which is negative 4. So 5 times negative 2 is negative 10. And then we have negative 2 and negative 4 is plus 8. What is negative 10 plus 8? That's negative 2. And guess what? That checks out. That checks out. All right? So since that checks out, ray status good, we're good. Negative 2, negative 4 is my ordered pair, or x equals negative 2 and y equals negative 4. All right? Let's look at another example here. Another example. We have 2x minus y equals 10 and x equals 2y minus 1. Again, I look at this and go, oh, yay, x equals, that's already, to me, this is the simplest, well, one of the simplest ones, okay, when it's already x equals or y equals. I'm going to take this, if I remember to plug in the right one. Plug this in for what? X equals, so plug this in for x. Plug that in for x. All right, so we're going to come over here and we're going to say, okay, this is going to be 2 times x minus y equals 10. And we're going to take this and plug it in here. 2y minus 1, right? Because it says x equals, right? Plug it in. So that's going to give us, let's see, wait. That's going to give us, when we distribute the 2, 4y minus 2, oops, not equals, minus another y equals 10, right? So this part becomes 4y minus 2, and then the minus y gets brought down. And that gives me, put these together, is 3y, and I'm going to go ahead and add 2 because I can't do anything else with that 2 on that side anyway, equals 12. Divide both sides by 3, and what do we get for y? We get 4. So y is 4. So put that in the second part of the order pair, right? Y equals 4. And then if I want to go back and find x, I know that x equals 2 times y minus 1. But what is y? It's 4. It's 4. That's y. Okay? So then, that's going to be what? 2 times 4 is 8. 8 minus 1, that equals x. And x equals what? 7. So put that in here. And then we're going to check it. We're going to check it. So x is 7. So I used the bottom equation, right? I used this equation to find my last variable here. So check it up here. 2 times 7 minus 4 equals 10. So 2 times 7 is 14 minus 4. Guess what? That's 10 equals 10, right? Checks out. So that works out. So that is the correct answer there, all right? 7, 4. X is 7. Y is 4. And then one more. 3x minus 5y equals 17, and 2x plus 3y equals 5. If I look at this, it's not x equals or y equals. If I add them together, right, this is 5x, this is negative 2y. That does not cancel immediately. And then I say, okay, there's no x equals y equals. I can't solve. The last thing I want to do is multiply by the opposite. So can I multiply 2 times anything and get 3? No, it's not a multiple. 3 and 5 are not multiples. So this is that situation where I swap the coefficients and change a sign. I got to swap the coefficients and change a sign. I can either go, swap these and go 2 and 3 and make one negative, or I can swap these two and put 3 and 5 and make this negative 5 positive, which I would like to do. I'd like to do positives if I can. So I'm going to take the top equation times 3, 3x minus 5y equals 17, and the bottom equation, not times negative, times a positive 5, 2x plus 3y equals 5, right? And then I'm going to write those two equations down. I'm just going to write them both over here, okay? So it's going to be 9x minus 15y equals 3 times 17 is 51, and then 5 times 2x is 10x plus 15y, and there we have it. That's what we were looking for, okay? Equals 5 times 5 is 25. All right? So the nice thing about it is when I add these together, 9x and 10x is 19x. This minus 15y plus 15y cancels, and I'm left with equals 51 and 25 is 76. So when 19x equals 76, I divide by 19 on both sides, and x is going to be 4. 76 divided by 19 is 4, right? And then, so I put x is 4, and x is 4. And then I say, okay, I need to find what? I need to find y. How do I find y? Well, pick an equation and solve. So this time, I'm going to do the bottom equation just because I've done the top equation so many times. I'm going to pick this equation and plug it in, right? So 2 times x, let me find some space. 2 times x plus 3y equals 5, okay? So right here, plug in x is 4, right? Have that plugging in right here. So if I solve this, we get 8 plus 3y equals 5. So I'm going to subtract 8 from both sides. 3y equals negative 3, divide by 3, and y equals negative 1. So kind of let me separate that out. So then put in here negative 1 for both of these. And then I'm going to check it in the top equation, right? Because I used the bottom equation to solve for y over here, right? Use the bottom equation. So I'm going to check it in the top equation. So 3 times x, which is 4. So 3 times 4, that's 12. Minus 5 times y, that's negative 1. Minus 5 times minus 1 is what? That's plus 5, right? Plus 5. So 12 plus 5 is 17. That equals 17, and it checks out, right? So then my final answer there is 4 comma negative 1, or x equals 4 and y equals negative 1. All right, so I hope this is a good introduction and helps you with solving systems of equations. I did several examples, maybe too many. This is kind of a longer video, but again, I thought the more examples you see, the better. And I talked through how I chose what to, method to use there. But if you're told to use a certain method, then you have to use that method. Hopefully, you're not told to use substitution here because you'd have some nasty fractions along the way. All right. But when I solve equations that involve fractions, I just multiply everything on both sides by the LCD to eliminate the fractions if you had to go down that road.